Hello, everyone. Welcome back to your channel of Math Made Easy and the series of probability. I'm sorry, of Trig. Uh, I was planning to do a probability session first, and then I got confused. I'm sorry. What I wanted to do today in trig functions is simplifying expressions. So we are going to do a simplifying expression this time, maybe solving linear or quadratic trig functions next time. And I think we'll stop here and we'll start maybe some other subject in math. If you have something that you want me to go over, maybe you can let me know in the comment sections. Otherwise, I'll think of something. So, simplifying expressions. Before we start, let's recap what we did or what identities we learned, and maybe I will add something that would help us today to that. Of course, the most famous function is that sine square of theta plus cosine square of theta equals 1. In fact, when I was doing a session in statics and we were using decomposition using sine and cosine, I mentioned that this is not an identity. That's a special case of a more generic identity with cosines. Again, if you already doing some engineering work, maybe you can visit that session and you will learn that this is, of course, it is an identity, but it's a special case of a more generic identity, as I said. Then when we divided right and left by cosine square, we got another identity that is derived from this one. So it's not like an independent one. That tan square theta plus 1 equals secant square theta. Okay, so the secant square is tan squared plus 1. Meaning if you have a triangle, one of the sides is tan theta and the other is 1, then the hypotenuse would be secant square. And then if you divide by sine square, you get 1 plus cotan square theta equals cosecant square theta. Same thing. Same thing. Okay, having said that, and then we did like the double sine, cosine, and tan formula, or the sum or difference between sine, cosine, tan of two angles. You can find the sine of A plus B, or the cosine of A minus B, or the tan of A plus B or A minus B. The only thing we didn't do is that remember when we drew the circle. So let's do a quick one here, faster than. And we said we had four quadrants. Oops. So we noticed that the cosine, all were uh, positive here, only the sine here and only the cosine here. I'm gonna leave the tan for now, but um, you can see that if the angle is positive or negative, its cosine is the same. So this is telling me that cosine of theta is the same as the cosine of negative theta. Interesting, right? Meaning, if I have an angle of 30 degrees or an angle of 330 degrees, they have the same cosine. And for that, we call the cosine function an even function. Even meaning if I take this function of x and the same function of negative x, I get the same result. This is like the square function. When you say f of 3 for a square, 3 squared is 9, and negative 3 squared is also 9. So that's why we call this even function, because it works like an even power. Okay? However, the sine on the other side, if I take a sine of x and a sine of negative x, you get the negative. And that's why we call that an odd function. Notice that if you take, say, the cube of negative 3, you get negative 27, which is the negative of cube of 3, which is 27, meaning the sine of theta is the negative of the sine of negative theta. That's why we call this an odd function. Notice the tan is the same thing because the tan is positive here. So if you take tan and tan of theta and tan of negative theta, they are the negative of each other. So the sine and the tan are odd functions. The cosine is an even function. That becomes sometimes important. One last thing I want to tell you is that, remember when we started Trig and I told you we decided to call the opposite over the hypotenuse as the sine, and then somebody said, what if we want the adjacent over the hypotenuse? And they said, if you go to the complementary angle of theta, that would be its sine. That's why we called it cosine, meaning the sine of the complement, which tells us that sine of theta equals cosine of 90 minus theta. I was going to write pi over 2, which we usually write it as. So in radian, we would say cosine of pi over 2 minus theta. So between these three, these are like not new, but I mentioned them for the first time because they may help us simplifying some expressions. We'll start with some easy expression. In the first one, they tell you to verify that secant square theta minus 1, if I divide that by secant square, I should get sine square. So when you are given a problem like that, you look at one of the sides. Of course, I'm going to do the left-hand side. Let's simplify the left-hand side. And if you know these, or if you only know that, you can always divide by sine or cosine to get what you want. I see a secant square, and I know that the secant square is tan square plus 1. So I write tan square theta plus 1, that's the secant square, minus 1, over tan square. Oh, tan square theta plus 1 is also secant square. So I could have left that, in fact, right? It would have been easier. It doesn't matter. Um, yeah, I think we don't need to do that. That's a lot of work. I should have thought of the problem before starting solving it. Because secant square minus 1, notice that if you subtract 1 from both sides, that becomes tan square theta, right? Tan square theta divided by secant square. I'm not going to switch it into tan square because there is no reason to do that. I can simply say over secant square because now I don't have any second term. There is nothing added or subtracted. So it's easier uh, to do it this way. Uh, which, by the way, could have been done here anyway. So I don't know why I canceled it. Doesn't matter. So tan square, we know that tan is sine over cosine. So I can write it as sine square theta over cosine square theta. And then when you divide by something, you can multiply by its reciprocal. And the reciprocal of secant is cosine. So the reciprocal of secant square is cosine square theta. So it equals the right-hand side. So that's an easy verification. In fact, I could have done it here as tan square over secant square, which we already have here. I don't know why I said, no, there's an easier way. It's the same thing, but verify that cotan theta uh, over cosecant In fact, instead of saying verify that, I would say stop the video and find what that is. Okay? Do it on your own and come back and check because I'm going to continue now. We want to verify that this is cosine of theta. Let's do it. Left-hand side. Verify the left-hand side or simplify the left-hand side. Cotan is cosine over sine. Cosecant in the denominator, 1 over cosecant is sine. So when you divide by cosecant, you can multiply by its reciprocal. Very easy. They cancel each other. And you get cosine, which is the right-hand side. So if you found cosine, and that should have been easy, you are correct. Okay. Let's take another one. Uh, hmm, let's verify also that cosine of theta divided by 1 plus sine theta equals, or yeah, 1 minus sine of theta over cosine of theta. In fact, here you don't need to verify. They usually don't tell you to verify. They say, prove that this is an identity. You say, oh, I don't see it here. Yeah, but you can make it up here. Think about it. That should be an easy one. Stop the video if you want. Try it on your own. Come back. Now I'm going to show the answer, okay? Of course, when you have two fractions like that, you know that you can use, some people call it the cross multiplication, some people call it the butterfly method, is that the product of these two should equal the product of those two. So when I multiply these two terms, I get cosine square theta, right? And when I multiply those, I get 1 plus sine of theta times 1 minus sine of theta. I look at these two and what do I see? Yes, the product of that is the difference of squares, right? You know that x plus y times x minus y equals x squared minus y squared. You know it usually the other way. They give you difference of two squares and you factor it as a plus b times a minus b or x plus y times. So I know that this would be, if x is 1 and I square it, it's still 1. Sine theta is y. When you square it, you get sine square theta. And we know that 1 minus sine square theta equals cosine square theta. So cosine square theta equals cosine square theta. So that's an identity. Or you could have added sine square theta to both sides. The left-hand side would be sine square theta plus cosine square theta, which is 1, and the right-hand side is 1. So you get 1 equals 1. That's, again, a verification, or we found that this is the case. Let's take one more, and then we stop here, and then I will tape a session right after this one for equations, either linear or quadratic. And I think that would be enough for an introductory course of trig. That's more than what you need, I think. If you are taking like or working with more advanced stuff, I made a session using using Pascal triangle to expand. So here we learned, last time we learned how to expand the sine of 2 theta, cosine of 2 theta, tan of 2 theta. I show you a way to expand the sine or cosine of any multiple of theta, like 10 theta, 7 theta, any number times theta from Pascal triangle. It's so interesting. If you watch it, I think if you are like having a good basis in trig, I think you would like that. But if you are still taking trig for the first time, I think it's too soon to watch that one. Okay, the last one, I wrote it down. It says, simplify cotan theta times cosine theta over tan of negative theta times sine pi over 2 minus theta. Remember, we did this stuff today, and that's why I went over the odd and even functions and the relationship between the sine and the cosine. Okay, again, stop the video, do it on your own. That should be an easy one, and then come back and check. Okay, the way we are going to do it, the numerator is easy. I know that the cotan is cosine of theta over sine of theta, and this is multiplied by cosine of theta. The interesting thing is down here, because tan of negative theta is negative tan theta first, and the sine of pi over 2 minus theta is cosine of theta. Remember, we said that. Now, the cosine and the cosine can simplify. And then I would say minus cosine of theta over sine of theta divided by something. So it's multiplied by the reciprocal, right? The reciprocal of tan is cotan. So instead of the denominator is sine over cosine, when I transform it, it becomes cosine theta over sine theta. So that becomes negative cosine square theta over sine square theta. You can call that negative cotan square theta, right? Because cosine over sine. So we started with cosine, we ended up with cosine, I'm sorry, with cotan and tan, and we ended up with cotan square at the end, but with a negative sign in between. And I think that would be it for today. Um, short session, and then next time I will prepare like 2 or 3 functions or equations, and we'll look at some of the pitfalls or the tricks and discuss those. Thanks for watching, and have a great day.